Um, Assalamualaikum and good evening. My name is MUADDIB bin MUZAFAR, and this evening I want to explain about Lab 5 for control principle subject. Okay, and we go to the objective. The objective is to derive a transfer function from system response for a first order and second order, and then to design and generate overdamped, underdamped, undamped and critical damped system, and then to identify the effect of pole location toward system response. Okay, the component or equipment that we need for this lab is just a computer and MATLAB software. Then we go to procedure. Alright, for procedure for part A, system response for first order. Okay, first step is find the closed loop transfer function of block diagram shown in figure 1. So we can see here the block diagram for figure 1, and as we can see here is my calculation to get the transfer function for the closed loop transfer function. And then for number 2, consider sk equal to 12 and a equal to 4. Generate the step response of the first order system for the transfer function obtained. To obtain the unit step response, you may use below MATLAB program as an example for system. Alright, and as you can see here, this is just a example. So we go to number 3. For number 3, from the graph obtained, find the time constant, rise time and settling time of the system. Okay, this is my coding for that MATLAB, and this is my calculation. Alright, and just a minute. Okay, we go to the for time constant, where we use 63% of final value. It is because of time constant can be defined as time it takes for the step response is rise up to 63% that, or 0.63 from its final value. So as you can see here in the calculation, we use 63% from the final value. This is the final value, that is 0.05, and we just multiply with the percentage, and then we got the time constant. And then for the rise time or TR, go back to the internet and rise time. Rise time is defined as the time with for the waveform to go from 0.1 to 0.9 or 10% to 90% of the its final value. This is the formula. Okay, we go to the calculation back. Okay, this is why I use 90% of final value and 10% of final value. So just like just now, we just multiply the percentage with the final value, and then we get the answer. Then we go to settling time of the system. Okay, settling time. Settling time is defined as the time for response for response to reach and stay within 2% of its final value, we can limit the percentage up to 5 of its final value. Both percentage are a consideration. This is the equation. Then this is for the time settling. Then this is the graph that I got. This is time at 10%, time at 90%, settling time, rise time, time constant. This is the answer for time constant, rise time, and settling time. And then we go to part B, system response for second order. Okay, system response for second order, we can see here. First step is for circuit figure 2, calculate transfer function for the circuit. From this circuit, I managed to get the transfer function, and this is the final transfer function. And then step 2, given the general second order transfer function equation is as below. As we can see here, this is natural frequency and damping ratio. Right. Number 3 is natural frequency is 1. C is capacitor is 1 microfarad and inductor is 1 mega henry. Calculate the resistor value for below condition. Okay, from the damping ratio and this info that have been given, we can see that I calculate manually. This is my calculation for condition 1, condition 2, condition 3, and condition 4. Okay, then we go to step 4, generate the step response for above 4 condition. Okay, for condition 1, this is I change the denominator to get this equation, and this is the step response. And for this condition, this of second order system can be classified as undamped response because it has pole at the origin that come from the unit step input and 2 imaginary poles that come from the system. Okay, and then we go to condition 2. Condition 2, we change the equation, the denominator, and this is what we call underdamped response because it has a pole at the origin that come from the unit step input and 2 complex poles that come from the system. Then we go to condition 3. This is the step response, and this is called critically damped response. It has a pole at the origin that comes from the unit step input and 2 multiple real poles that come from the system. And then we go to the last condition, that is condition 4. Condition 4 is overdamped response. It has pole at the origin just like the other that come from the unit step input, and there's 2 real poles that come from the system. Okay, I think that's all from me. Thank you.